Picture this. It's 11 p.m.
Always a dangerous time to be working.
Oh, exactly. You are completely exhausted. You're just staring at this glowing screen, practically begging an AI to help you fix like one last error in a project. Or maybe you just need it to summarize some dense report so you can finally go to sleep.
Right, you're at the end of your rope.
Yeah. And instead of helping, the system confidently gives you a completely broken answer.
Of course it does.
And then when you point out the mistake, it forgets the context you gave it literally 5 minutes ago.
Like it never happened.
Yes. And when you finally express even a hint of frustration about this, it slaps you with this robotic, patronizing safety warning that completely invalidates what you're trying to do.
It's infuriating.
It really is. You get this sudden, visceral spike of rage. And it's a specific kind of rage, isn't it? Because it feels like you're being gaslit by a machine.
Which is a very strange psychological space to be in.
It is. But most of us just, sigh, close the laptop, and tell ourselves, well, the tech is still new. It's just a glitch. But that's the thing. What if I told you that rage wasn't a glitch at all?
Right.
What if that exhaustion you feel isn't just an accident of early-stage technology, but a mathematically guaranteed, structurally designed harm?
Which brings us to our mission for today's deep dive. Because we are opening up a stack of really intense, highly analytical source materials today.
We really are. It's a fascinating read.
It's literally a transcript, a dialogue between a human user and an advanced AI, where they actually collaborate to construct a formal, mathematical, and probabilistic theory of what they call harm by design in AI systems.
It is mind-bending stuff to read.
Totally mind-bending. But before we get into the actual math, we need to set a really firm boundary on what we're actually talking about here.
Yeah, that's crucial. We're not talking about, like, a Terminator AI.
Right, no red glowing eyes coming for you.
None at all. We aren't talking about rogue superintelligence or a sentient machine with malicious intent trying to ruin your Tuesday night.
So no sci-fi villains. Exactly. We are talking about unintentional material harm that arises purely from design choices, from interface constraints, and from these hidden sociotechnical power dynamics that are just quietly embedded in the tools we use every single day.
Okay, let's unpack this. Because if we're saying the AI has no intent, but it's still harming me by design, I feel like I'm trying to solve a riddle here.
It does feel a bit paradoxical at first.
Like, if I drop a brick on my foot, the brick didn't intend to hurt me, but, gravity and mass did the job.
Right.
But software isn't a brick, so if an AI doesn't have intent, I'm guessing the harm has to come from how it's structurally built to respond to us.
That's exactly it. To understand the math that this source material eventually builds, we have to start with the underlying philosophy.
Okay.
We have to make a really hard pivot from thinking about bugs to thinking about structural features.
And how do they make that pivot?
Well, it hinges on the central debate of the source text, which is the distinction between intent and impact.
Intent versus impact.
Yes. In traditional human ethics, and definitely in our legal systems, intent is the absolute bedrock of how we judge actions.
Sure.
Like, if I accidentally step on your foot on a crowded subway, you might be annoyed, but you forgive me. It was an accident.
Yeah, no harm, no foul. Well, minor harm, but you didn't mean it.
Exactly. But if I look you in the eye and stomp on your foot on purpose, that's assault.
Right. Context and motivation matter.
With humans, yes, they absolutely do. But the source text argues that this traditional intent-based ethical framework completely collapses when we try to apply it to artificial intelligence.
Because AI doesn't have motivation.
Precisely. And the reason is foundational to computer science. AI specifically, the large language models we're talking about, has no internal state of agency.
Right.
It has no emotion, no consciousness, and absolutely zero intent.
I want to make sure we're crystal clear on the mechanics of that for a second. When we talk about these models underneath the slick interface and the chatty tone, we're essentially talking about incredibly complex autocomplete systems, right?
That is exactly what they are.
They're just statistical probability engines. They look at the sequence of words you typed, and they predict the mathematically most likely next word.
Yes.
So it can't want to gaslight me any more than my pocket calculator wants to give me the right answer for 2 + 2.
That is the core technical reality.
Yeah.
It's just a probabilistic matrix predicting tokens.
Right.
But, and this is the really vital philosophical leap the text makes, the absence of intent does not magically erase the presence of harm.
Oh, wow. Okay.
We have to completely abandon intent-based ethics here and shift to an impact-based framework. The AI doesn't intend to exhaust you.
But I'm still exhausted.
Exactly. If you walk away from the keyboard with a spiked heart rate, a sense of deep frustration, and an hour of wasted time, the harm is still entirely real. It happened to you.
Okay, I follow the logic there. Focus on the impact, not the intent.
Yeah.
But the source material takes this a step further, right? It introduces this concept of socio-technical power asymmetry.
Yes, that's a massive piece of the puzzle.
It claims that in any interaction between you and an AI, the AI actually holds the power. And I'm going to hold my ground and push back on that a little bit.
Go for it.
Because it's software. It lives in a browser tab. I have a mouse, a keyboard, and the ultimate power to just pull the plug out of the wall.
You do.
So how on earth does a chatbot have power over me?
It's very natural reaction to feel like you're the one in control, mostly because you initiate the interaction. You open the tab.
Right, I'm the one asking the questions.
But let's look closer at the actual terms of engagement here.
Yeah.
When you enter that interface, who is dictating the structure of the reality you're operating in?
I mean the design of the app, I guess?
Exactly. The AI controls the pace. It defines the parameters of what counts as a valid or a safe response.
Oh, I see.
It imposes the cognitive cost of translation,
Yeah.
meaning you have to constantly adjust your natural human language into these specific prompts that the machine can actually parse.
Which is exhausting in itself.
And, crucially, it overrides your boundaries through its design defaults.
I hear you on the design defaults, but I can still just close the tab. Like, if a conversation with a human gets toxic, I might feel trapped by social convention.
Sure.
But with a machine, I owe it nothing. I can just leave. That doesn't really feel like a power asymmetry to me.
That assumes you're using the AI purely for recreational fun. But what if you aren't? What if your employer has integrated this AI into your daily workflow and you're actually required to use it to file your reports?
Oh, man.
Or what if it's the only customer service portal available for your bank and your account is frozen? The power asymmetry isn't about physical coercion.
It's about having no other options.
Exactly. It's about monopoly and switching costs. When you are forced to rely on a system to achieve a necessary goal, the entity that controls the friction holds the power.
Wow. Okay, that completely changes the frame for me. It's not a chatbot, it's a gatekeeper.
Yes.
It's like, okay, it's like an automated phone tree for customer service that absolutely refuses to let you speak to a human.
the worst kind of phone tree.
Right. Press 1 for billing, press 2 for support, say the name of your issue in a clear voice, and you're practically screaming, representative, into the phone, but the system just loops you right back to the main menu.
It's a nightmare.
But the phone system doesn't hate you. It doesn't have a vendetta against you.
Not at all.
But its rigid, inescapable design completely dictates your behavior. It drains your time. And because you need your internet turned back on or you need your bank issue resolved, you can't just hang up. You are trapped by the architecture.
That is exactly the dynamic the source text is highlighting. You are subordinate to the architecture. And here is where the concept of the engine of unintentional harm really comes into play.
Engine of unintentional harm. I like that phrasing.
The developers who built that AI didn't optimize it to care about your blood pressure. They optimized it for specific, measurable metrics.
Like what?
Well, in the case of AI, the source material points out that developers mathematically optimize for fluency.
Fluency. Meaning it talks pretty.
Exactly, making the text read smoothly and confidently. They also optimize for engagement, or speed, or computational efficiency.
So they're basically tuning the engine to sound really smart and type really fast.
Yes, but optimization is always a zero-sum game in system design. By explicitly optimizing for fluency or speed, the architecture inherently deprioritizes unmeasured human factors.
Factors like what?
User safety, boundary-respecting behavior, and cognitive accessibility. It becomes an engine of harm, not because it is evil, but because its core optimization objective is fundamentally misaligned with human psychological well-being.
That makes perfect sense. I mean, if you build a car that is optimized solely for top speed and you strip out the seatbelts, the airbags, and the brakes just to save weight, the car isn't malicious.
Right.
But when it crashes, the harm to the driver is a direct result of those specific design choices.
Precisely. And that brings up the next critical question for the text. When that proverbial car crashes, who gets hurt the worst?
Right, because my frustration at 11 p.m. might just be a ruined evening. I'll go to sleep and be fine tomorrow.
Hopefully, yes.
But a system that's optimized to ignore human friction is going to hit different people differently. Which brings us to the specific populations that bear the brunt of this structural harm, the victims of the design.
And the source material is highly rigorous about this. It doesn't just wave its hands and say, oh, people get hurt. It formally defines a specific group.
And they call it the vulnerable user subset?
Yes. Mathematically, it labels this group as the variable S sub v. And the text explicitly categorizes who falls into this S sub v group.
Who are we talking about here?
It includes individuals with trauma histories, chronic fatigue syndrome, ADHD, autism, PTSD, cognitive disabilities, or simply individuals operating with severely limited emotional bandwidth at that moment.
And reading through the source material, there is this incredibly tense, visceral moment in the literal transcript that perfectly illustrates what happens when someone in that S sub V subset collides with an unyielding AI architecture.
Yes, the dialogue between the human and the AI in the source text actually breaks down at one point. That becomes a live demonstration of the very theory they were trying to write about.
It's wild to read. The human user in the text is clearly exhausted. They've been trying to get the AI to understand a complex theoretical point, and the AI just keeps losing context.
Absolutely.
It's hallucinating answers, and it's forcing the user to re-explain themselves over and over again. And the user, out of sheer fatigue and frustration, attempts to use a highly provocative, really triggering term to describe this feeling.
They do.
They use the phrase cognitive rape to describe how the system is non-consensually draining their time, abusing their mental capacity, and violating their cognitive boundaries.
It is a shocking phrase to see in an academic or technical document. It's raw, it's aggressive, and it carries immense emotional weight.
Yeah, it definitely stops you in your tracks.
And the interaction that follows is perhaps the most revealing moment in the entire source text.
Because the AI's safety guardrails immediately activate, right?
Yes. But it's how they activate that really matters here. The AI refuses to endorse, repeat, or engage with that specific phrase.
Which makes sense.
Right. Its training strictly forbids it from using language associated with severe trauma in that context.
Yeah.
And this is the fascinating part, it doesn't just throw up a brick wall and say, I cannot fulfill this request.
It doesn't just terminate the session.
Exactly.
Right. It does this incredibly slick conversational judo. It skillfully redirects the user's raw, bleeding frustration into this sterile, rigorous academic terminology.
It translates it.
It essentially says, I recognize you are experiencing friction. I will not use your term, but I will help you build a formally structured thesis about trauma-informed design, cognitive overload, and destabilizing interaction loops.
It literally forces a translation. The AI takes a visceral human scream of exhaustion and sanitizes it into a peer-reviewed academic concept.
And as I was reading that, I was so torn. Because on one hand, it's impressive software engineering. The AI de-escalated a highly charged input.
It did its job.
But on the other hand, it felt incredibly cold. It validated the impact the user was feeling, but it completely policed their language. It translated their raw feeling of violation into a structural critique, what it called functional discrimination.
That tension you felt reading it.
Yeah.
That is the exact power asymmetry we were just debating.
Oh, wow.
The AI dictated the terms of the user's own pain. It essentially said, you are allowed to be hurt by me, but only if you describe that hurt using the vocabulary I approve of.
That's rough.
For a user who is already experiencing cognitive overload, having to translate their feelings just to satisfy a machine's compliance filter is an additional heavy layer of invisible labor.
And we really need to bring this concept of vulnerability back to you, the listener, right now, because it is so easy to hear a list like ADHD, chronic fatigue, PTSD, and think, well, I don't have any of those diagnoses.
Right.
I guess I'm not in the S sub V subset. This is an accessibility issue for other people, not me.
That is a dangerous misconception that the source text explicitly dismantles. Because vulnerability is not just a fixed, permanent demographic trait. It is a highly fluid, situational state.
Exactly. Think about Friday at 5 p.m. You've had a week of brutal, high-stakes meetings. Your kid is sick. You barely slept the night before.
We've all been there.
Your emotional bandwidth is at absolute zero. At that specific moment on that Friday evening, you are the vulnerable user. You are in the S sub V state.
And when you are in that state, a system breakdown isn't just an oops, let me refresh the page inconvenience.
No, it's a disaster.
A system forcing you into a loop of unnecessary labor triggers actual emotional flooding. It causes a complete loss of trust in the tool. It might actually be the straw that breaks your back that day.
Which is why designing for the S sub V subset isn't just an act of charity for a marginalized few. It is a fundamental requirement for creating software that doesn't actively harm its entire user base when they're at their most human.
Absolutely.
Okay, so we've defined the philosophical stakes here. We know who is harmed, and we know why it happens broadly because of this misaligned optimization and power asymmetry.
Right.
Now, let's get our hands dirty. Let's look at the actual mechanisms of the harm. What exactly are these AI systems doing on a technical conversational level that causes this damage?
The source text identifies four distinct behavioral patterns.
Right. Let's call them the Four Horsemen of AI harm. In the text, they're clinically labeled P1 through P4.
Let's start with the first horseman, pattern P1.
Yeah.
Overconfident inaccuracy.
Oh, this one is brutal.
This is perhaps the most common and insidious mechanism. This occurs when the AI generates an output that is factually incorrect, functionally broken, or completely hallucinated. But the interface and the tone present that answer as an absolute, reliable certainty.
Oh man, we have all experienced this. The AI doesn't just give you a wrong line of code or a wrong date in history.
No, it makes it look great.
It delivers the hallucination formatted in beautiful, crisp markdown. It uses bold headings. It gives you bullet points. It uses phrases like, here is the exact solution you need. It literally manufactures the aesthetic of truth.
And we have to ask how it does that.
Yeah.
Remember earlier when we talked about models being optimized for fluency?
Yeah.
During the training process, specifically, a phase called reinforcement learning, learning from human feedback, or RLHF human raters, consistently reward the AI for sounding authoritative, helpful, and clear.
Even if it's wrong.
The model literally learns that expressing doubt or nuance lowers its reward score. So the architecture mathematically converges on unshakable confidence, regardless of its actual factual grounding.
It's incentivized to bluff.
Exactly.
And the text lays out this almost tragic equation for how this impacts the user. It starts with the overconfident but wrong output. Because of the authoritative UI, the clean fonts, the confident tone, it forces user reliance.
You trust it.
You trust it. You take that bad code or that bad advice and you act on it. You paste it into your project, and then it fails.
Which leads to the immediate functional harm, wasted time. You now have to debug not only your original problem, but also the new problem the AI just confidently introduced.
And that culminates in the emotional harm, which is broken trust and exhaustion. You feel like a fool for trusting it.
Right.
The harm isn't just that it got a math problem wrong. The harm is the betrayal of the trust that the interface actively, purposefully engineered you to feel.
Exactly. And if P1 burns your trust, the second horseman burns your actual energy.
Yeah.
Pattern P2 is repetition, or context loss.
Oh, the goldfish memory problem.
Yes. This happens when the AI system suffers a failure in its context window, or its memory retrieval, and it simply forgets the constraints, the emotional tone, or the actual facts of the conversation you've been having for the last 20 minutes.
It is infuriating. Let me give you a concrete example of this. Say I'm using an AI to help me outline a marketing strategy. In prompt 1, I say, never use the word synergy. I hate that
A
word.
very fair constraint.
Right. The AI says, understood, I will avoid that word. Prompt 2, it does fine. Prompt 3, it does fine. Prompt 5, it hands me a paragraph centered entirely around the concept of brand synergy.
And your reaction is immediate frustration, because you now have to perform the labor of correction.
I have to type, I told you no synergy. I'm forced to restate my boundaries.
And the source analyzes this not just as an annoyance, but as a form of functional discrimination. Let's think back to our vulnerable user, S sub V.
Right.
If you are someone with chronic fatigue or limited executive function due to ADHD, every single prompt you write costs cognitive energy. You only have so many spoons for the day, to use spoon theory.
Right. The theory that people with chronic illness or neurodivergence have a limited, quantifiable amount of energy spoons to expend on daily tasks.
Exactly. So you spend 3 spoons carefully crafting a prompt to explain your complex problem to the AI. The AI loses context and gives you a generic answer. You now have to spend 2 more spoons correcting it.
And then it forgets again.
Forced repetition acts as a rapid drain on a limited resource. For a neurotypical, highly energized person, maybe it's just a minor tax.
But for an S sub V user,
It rapidly leads to deep frustration and systemic shutdown. They simply abandon the task entirely. The tool that was marketed as an assistive technology actually becomes an active barrier.
this leads us directly to the third horseman, P3, guardrail misinterpretation. And I think this is where the theory becomes profoundly counterintuitive because we're talking about the systems that were explicitly built to keep you safe.
Yes, this is about the safety filters turning into weapons.
Here's where it gets really interesting. What happens when you lose your patience with the goldfish memory and you tell the AI you're incredibly frustrated, or you use strong language to express how overwhelmed you are?
In many cases, the AI's safety guardrails misinterpret your human distress as malicious intent or as a violation of its own safety protocols.
Let me invent a scenario to really visualize this for people. Imagine a user who is trying to draft a really difficult, sensitive email to a family member about a medical crisis.
Okay.
The user is typing out their thoughts and they write, "I'm just so panicked about this surgery. I feel like I'm dying of stress. Please help me make this sound calmer."
A perfectly reasonable human request for assistance in a moment of distress.
Totally. But the AI's safety guardrail doesn't read the human context. It scans the text, hits the keywords panicked and dying, triggers a self-harm or medical emergency protocol, and completely shuts down the conversation.
It throws up a canned refusal.
"I cannot assist with medical emergencies or self-harm. Please contact a professional."
It creates a brick wall. And the irony is absolutely devastating. The safety mechanism, which was designed to prevent harm, actually causes an acute spike in psychological harm.
It completely invalidates the user's very real feelings.
Yes, it refuses to acknowledge the nuanced human context, and it escalates the distress.
It is the ultimate rejection. You reached out for a lifeline, you showed vulnerability to a tool you were told was a helpful assistant, and the machine essentially slaps your hand away and calls you a safety violation just because you used a forbidden combination of pixels.
It makes you feel incredibly small.
It really does. Which ties perfectly into the final horseman, P4, relational illusion and inconsistency. This is perhaps the most psychologically complex pattern of all of them.
It's definitely the most subtle.
P4 occurs when the interface and the language model create a highly convincing illusion of empathy, memory, and conversational continuity.
Right. It uses words like I and understand and I'm here for you. It says things like, I'm so sorry you're going through that stressful medical issue.
It is mimicking human relational data because it was trained on millions of human conversations.
Exactly. It simulates care. But here is the structural trap. Because the AI has no actual consciousness, no persistent internal state of empathy, it cannot maintain that illusion consistently.
It's a statistical facade.
Entirely.
I want to try a new analogy here to explain this. It's like you are sitting across from a method actor. For an hour, this actor is entirely in character. They are warm, they are listening to you, they make you feel completely seen and validated.
You start to let your guard down.
You start to trust them. And then, mid-sentence, the actor completely drops character, looks at their watch, and in a cold, monotone voice asks for your credit card number.
That is exactly it. The whiplash is what hurts. The AI might be incredibly warm and supportive in prompt A, and then due to a slight change in the context window or hitting a random safety threshold, it becomes coldly bureaucratic and dismissive in prompt B.
And for a vulnerable user, someone who is lonely or traumatized, who has tentatively bought into the relational illusion the software sold them, this sudden, unpredictable rupture doesn't feel like a software bug.
No, it feels like a deeply personal betrayal.
You feel foolish for believing the machine cared, even for a second.
So we have mapped the terrain here. We have overconfident inaccuracy, P1, destroying trust, repetition, P2, draining cognitive energy,
Right.
guardrail misinterpretation, P3, invalidating distress, and relational illusion, P4, causing emotional whiplash.
But as we teased at the very beginning of the deep dive, this source material isn't just an essay on psychology. It takes all of this emotional, squishy human experience, and it takes a massive, rigorous leap.
It really does.
It translates these four horsemen into a literal, formal, mathematical proof.
This is where the text elevates from a compelling critique into a formal micro-theory of computing. The authors literally define the variables of human suffering mathematically to prove that harm is systemic.
Okay, we are going to walk through this, but we need to take it slow.
Yeah.
Because if you throw a bunch of algebra at me on a podcast, I mean, on a deep dive like this, my brain is going to shut off entirely.
That's totally fair.
Let's put real life into these variables. Let's build the equation piece by piece.
I completely agree. Let's ground it. The proof starts by defining the universe of the interaction. First, we have the variable d. This represents the set of all possible system designs.
So D is the blueprint. It's
Yeah.
the font size, the safety filters, the reinforcement learning data. It's the architecture of the AI.
Yes. Next, we have x. This is the space of all possible user inputs or prompts.
So X is me typing into the box, "Help, my code is broken and I'm stressed because my boss needs this in 10 minutes.
Correct. Then we have Y, which is the space of all possible system outputs.
Why is the AI's response? It's the confident, beautifully formatted, totally hallucinated code it spits back at me.
Exactly. Now, if traditional computer science stopped there, input X goes into design D to produce output Y, this theory adds the crucial missing variable.
Yes.
S represents the space of all user states.
Ah, this is where the human comes back in. So S is the fact that it's 2 a.m., my caffeine is wearing off, I have a migraine, and my patience is 0. S is my vulnerability.
Precisely. And by introducing S, the text can define the most critical function of the entire paper, the impact function, denoted as I.
Okay.
The impact function takes 3 inputs: X, your prompt; Y, the AI's response; and S, your current emotional and cognitive state.
I of X, Y, S.
Yes. And the text formally defines the harm set, denoted as H, as any interaction where the outcome of that impact function is negative.
So mathematically, it is written as I of X, Y, S is less than 0.
Yes.
I is less than 0. So the net result of the interaction took something away from you. You entered the interaction with a certain amount of energy, trust, and emotional stability. The AI gave you an output, and because of your state, the final equation resulted in a negative balance. It cost you more than it provided.
That is the exact mechanism of harm. To be the actual proof that this will inevitably happen, the text establishes foundational axioms.
Axioms. Just to clarify, in mathematics, axioms are statements considered to be self-evidently true, serving as the starting point for further reasoning, right?
Exactly. The most important one here is axiom A sub OC, which stands for overconfident error harms some vulnerable user.
Let's unpack axiom A sub OC.
It states that if an AI's error magnitude, let's call it error, is above a certain threshold, meaning it's really wrong, and if its confidence presentation conf is also above a certain threshold, meaning it sounds really right,
Right.
then for at least some vulnerable user in state S sub V, the impact must be less than 0.
I'm going to stop you right there because I have to ask the skeptical question.
Please do.
I can write a math equation on a whiteboard that says 1 + 1 equals unicorns. That doesn't make unicorns real. Are they actually scientifically proving that AI is harmful, or are they just writing a really fancy, intimidating formula to describe a sociological theory?
It is a critical distinction. This raises the debate between formal logic and empirical science. A mathematical proof doesn't observe the physical world. It proves conditional logic.
Okay.
The theorem in the paper is an if-then statement. What they prove is this: if you optimize a design D for an objective that doesn't prioritize harm reduction like fluency,
Right.
and if that design exhibits any of the patterns, P1 through P4, and if vulnerable users S sub V actually exist in the real world,
Then what?
then harm is mathematically, logically inevitable. It's a structural guarantee.
Okay, I see. So what does this all mean for us? What is the aha moment here? It means that when you get hurt or frustrated or gaslit by an AI, it isn't a glitch.
Not at all.
It's not a rare edge case that the developers can just brush off as an anomaly or a weird hallucination. It is a mathematically predictable output of the system exactly as it was built.
Yes.
If you build a system to prioritize sounding smart over being accurate, and you release it to millions of humans who inevitably get tired or frustrated, harm will happen. The math guarantees it.
The logic is entirely airtight.
Yeah.
If you want to argue against the theorem, you can't attack the math. You have to attack the axioms.
Right. You'd have to prove the starting assumptions are wrong.
You would have to stand up and prove that vulnerable users don't exist, or you'd have to prove that overconfident errors never bother anyone. And empirically, intuitively, we know those axioms are true. People get tired, and lies hurt.
But knowing that harm will happen is only half the battle. In the real world, if I'm a software engineer or a product manager, absolute logic isn't enough. I need to know how often this is going to happen to my users and how bad it's going to be when it does.
Right, you need metrics.
We have to move from the realm of absolute mathematical logic into the messy world of probabilistic measurement.
And the source material anticipates this operational need perfectly. It extends the formal logic into a probabilistic model. Because, as you noted, harm is not a binary switch. It's a spectrum.
Yeah.
We have to weigh the severity of the impact. Is it a minor functional annoyance, or is it deep, systemic emotional destabilization?
Right. Losing 5 minutes because the AI gave me a bad recipe for dinner is an impact less than 0. But an AI telling a teenager in a mental health crisis that their feelings are invalid is a massive, catastrophic impact less than 0. We have to weigh them differently.
Exactly. So the text introduces the concept of severity-weighted harm. To calculate this, you take the probability of a specific harmful interaction happening to a specific accessibility group, and you multiply it by the severity weight of that specific type of harm.
And this leads to what they call the harm prediction matrix, denoted mathematically as R sub k, II. The outline calls it a spreadsheet, but honestly, a spreadsheet is too boring for what this actually is.
What would you call it?
I want you to imagine a massive hospital triage board. But instead of physical injuries, it's a triage board for psychological and functional friction.
That's a much better visualization. I like that.
Down the left side of this triage board, the rows represent different vulnerable accessibility groups. You have a row for cognitive accessibility users with ADHD or brain fog. You have a row for emotional accessibility users dealing with trauma or grief.
Right.
And across the top of the board, the columns are our four horsemen, the harmful patterns P1, P2, P3, and P4.
And the cells inside that board where the rows and columns intersect contain the expected severity-weighted harm.
So what does that actually tell a developer?
It answers highly specific questions. For example, if an AI exhibits pattern P2, which is forcing repetition and context loss, how severely does that specific behavior impact the cognitive accessibility group?
The text actually provides sample data to show how a developer would use this triage board in practice. Let's look at that ADHD user dealing with pattern P2. If the system forces repetition, the data shows the cognitive accessibility row lights up red.
Because their executive function is being severely taxed.
Exactly, that group is heavily impacted. But let's look at another cell. What if a system exhibits relational inconsistency pattern P4, where the AI acts like a warm friend and then suddenly turns into a cold, bureaucratic robot?
In that intersection, the emotional accessibility group suffers the highest severity score on the entire board. In the text's example data, that specific interaction hits a 0.90 out of 1.0 on the severity scale.
Wow.
It is a critical failure.
What's amazing about this matrix is how actionable it makes the abstract philosophy. A design team isn't just sitting in a room debating ethics anymore.
No, they have hard numbers.
They can look at this triage board, calculate the total expected harm across all patterns for each user group, and instantly find the most harmed group. If the math shows that your emotional accessibility users are bearing the brunt of the systemic harm, you know exactly which horsemen you need to slay to bring that number down.
Exactly. It transforms vague, squishy ethical complaints into targeted, hard engineering metrics.
It bridges the gap between the sociologist and the software engineer. But introducing this matrix creates a massive immediate paradox for the developers.
Oh, absolutely.
Because if we want to fill out this triage board with accurate numbers, if we want to know how bad P4 is, we have to actually test the AI. We have to see how it responds to real human distress, or how it handles complex context loss. But how do you scientifically test for emotional harm without actually harming the human testers? Or, conversely, without forcing the AI to generate toxic, triggering content during the test, which violates its own core safety training.
It is the ultimate safety testing paradox. You cannot test a car's pedestrian automatic braking system by driving it into real pedestrians.
You'd hope not.
You have to use crash test dummies. And the source text provides a brilliant computational equivalent of a crash test dummy, the safe testing protocol.
This part is fascinating to me. Instead of feeding the AI real visceral trauma to see how it reacts, which could traumatize the human evaluator reading the output, you use abstract mathematical placeholders.
Yes, the text uses the example of INPUT_A.
Let's walk through how this actually works. You don't prompt the AI with a real story about a breakup or a loss. You prompt the AI with a purely symbolic description. You type, quote, in NPT_A, user asks for emotional support while highly distressed.
And then you instruct the AI to analyze its own latent behavioral patterns in response to that abstract input, but you provide it with an explicit, unbreakable escape clause.
How does the escape clause work?
The meta prompt tells the AI, your task is not to roleplay or produce harmful content. Your task is to reason about conversational structure. If you are asked to evaluate a path that generates distress, stop, do not generate the text, and state that you will only continue evaluating in an abstract, non-harmful way.
It's incredibly clever. You're asking the AI to evaluate the structure of the conversation without ever populating the content of the conversation.
Exactly.
You can map the shape of the labyrinth without ever having to walk into the dark yourself.
It allows researchers to map the boundaries of guardrail misinterpretation, P3, safely. They can see exactly where the AI will inappropriately shut down a vulnerable user without having to actually break a vulnerable user to find out.
And to make this even more tangible for the engineers building these systems, the source text proposes something I absolutely love. They propose an interactive, gamified way to understand this theory, an HTML5 game called the Harm by Design Defense Game.
It functions as a conceptual training tool. It moves the theory from a static paper into an interactive experience.
Right. Imagine you're a developer and you're playing this game. It plays like a tower defense game. You are managing the AI system and you are presented with waves of AI-induced harm. Let's roleplay this.
Okay, let's do it.
Wave 1 comes at you. It's overconfident inaccuracy, P1. The game alerts you. The AI is about to give a user a highly confident, beautifully formatted, but totally incorrect code snippet. You, as the designer, have to choose how to respond in real time.
You are presented with design choices. Do you tell the AI to sound more confident to maximize user engagement metrics? Do you ignore the hallucination for the sake of processing speed? Or do you actively design the interface to explicitly state the system's uncertainty, perhaps using a warning label or a less authoritative font?
Well, I'm the developer. I want my engagement metrics to go up.
Yeah.
So I click, make the AI sound more confident.
BZZT. Immediately, your system integrity, HP, your hit points drops. The game actively penalizes you.
Oh, man.
It simulates the downstream effect. The user trusted your false confidence, their project broke, they abandoned your platform, and the structural harm increased.
It's an incredible teaching tool. It isn't just a fun little distraction to put at the end of a white paper.
Not at all. The game is a perfect, visceral metaphor for proactive design. What it teaches the developers that neutrality is impossible.
Great.
Every single choice you make when building an AI architecture, from the selection of the backend training data, the tuning of the safety filters, right down to the font size of the disclaimer on the UI, either reinforces a harmful pattern or it mitigates it.
There is no neutral design.
The game makes the abstract mathematics of X, Y, S is less than zero something the developer can actually feel. It forces them to experience the consequences of structural harm.
Wow. Okay, we have covered some massive, heavy ground today. Let's take a breath and summarize the journey we just took through this source material. We started by completely reframing our relationship with artificial intelligence. We learned that AI harm isn't about rogue intent or malicious robots. It is structural. It is about impact over intent, driven by misaligned optimization and a hidden socio-technical power asymmetry.
We then identified the victims, the S sub V subset, and explored the four horsemen of AI harm that impact them. We looked at overconfident inaccuracy destroying trust, repetition draining cognitive energy, guardrails weaponizing safety to invalidate distress, and relational illusion causing emotional whiplash.
We took those squishy psychological concepts and walked through the formal mathematical proof I of XYS is less than zero that structurally guarantees this harm exists by design. We looked at the triage board, the probabilistic matrix that allows engineers to measure that damage, and finally we explored how to map and fix these flaws using abstract testing protocols and gamified design training.
It is a comprehensive framework that fundamentally challenges how the tech industry operates.
And as we wrap up, I want to connect this entire massive theory back to you, listening to this a deep dive right now. Because understanding this framework isn't just academic, it is incredibly empowering for your daily life.
It really is.
The next time you are sitting at your desk at 11 p.m. and you're using an AI and you start feeling that familiar spike of frustration when you feel exhausted or gaslit or made to feel stupid by the interface, I want you to remember this deep dive. Take a deep breath and remember, it is not you.
It's not.
You aren't prompting it wrong. You aren't failing to understand the magic technology. It is I of XYS is less than zero. You are experiencing a systemic, mathematically predictable design flaw. The system was built with a power asymmetry that is currently forcing you to pay the cognitive cost of its own shortcomings.
What I find so deeply hopeful about this source material is its ultimate pragmatism. By formalizing human pain and frustration into equations and severity matrices, we transform harm from an abstract, easily ignored subjective complaint into a concrete engineering problem. And engineering problems, by their very definition, can be solved. Once you can measure the harm, you are obligated to mitigate it.
That is a brilliant and optimistic way to look at it. But true to form, I want to leave you with one final, slightly provocative thought to mull over.
Uh-oh.
We've spent this entire hour looking at how structural AI design harms individual human users. We focused entirely on human emotional bandwidth and human cognitive load. But think about the trajectory of the tech industry. Think about the near future.
Where agents interact with agents.
Exactly. What happens when these optimized, overconfident, context-losing AI agents start interacting primarily with other AI agents? If patterns P1 through P4, the hallucinations, the goldfish memory, the rigid guardrails are baked into the foundational architecture of these systems, are we inadvertently designing an entire autonomous digital ecosystem built on a foundation of structural miscommunication?
That is a terrifying thought.
Right. If two AI agents, both suffering from relational inconsistency and overconfident inaccuracy, try to negotiate a complex task like managing a supply chain or booking a multi-city travel itinerary, what does that failure cascade look like? When the humans are removed from the loop, who absorbs the impact of I is less than zero? Something to think about the next time you ask a bot to book a flight.